Hello everyone, welcome to VK Jain Sir Ki MEP classes. I am architect Neha Vasim, the owner of Praman Design Studio and Vinaya the learning platform. Today we'll talk about module S1, which is Sustainable and Intelligent Buildings. Building ecology. Building ecology is the study of interior relationships between human occupants, the built environment and the natural world, aiming for sustainable, energy efficient and healthy structures. It integrates building science with ecological principles to minimize resource depletion, reduce waste, and manage the metabolism of buildings, which often includes passive design and sustainable material choices. Building ecology and life cycle thinking integrate environmental sustainability throughout the building's existence from the raw material extraction to demolition. This holistic approach aims to minimize embodied energy and operational energy and waste by analyzing the entire lifespan, often the life cycle assessment to inform decisions early in the design process. Key aspects of building ecology include: first, healthy indoor environments, a focus on indoor air quality, thermal comfort and acoustics, ensuring the building supports the physical and psychological health of its occupants. Second, environmental impact mitigation. Buildings are designed to work in harmony with the natural environment, often utilizing climate responsive envelopes for natural cooling and heating. Third is life cycle approach. This involves selecting materials that are renewable, recycled, or locally sourced with a focus on low embodied energy, as seen in the work on building materials and their impact, say studies. Fourth is system thinking. The built environment is viewed as a network of interrelated systems like energy, material, water, and air that should mimic nature's efficiency. And fifth one is bioreceptivity, a concept of exploring how buildings materials interact with and allow colonization of living organisms, which is crucial for long-term durability and ecological integration. Essentially, building ecology aims to transform the building industry from a major concern of resources into an active participant in restoring environmental health. What is building ecology? Building ecology looks at a building as a living system interacting with the following. First, natural environment like air, water, soil, and climate. Second is human occupants, their health, comfort, and productivity. And third is resources like energy and materials. It combines principles from architecture, environmental science, and building and engineering. Let's understand the core principles of building ecology. First is energy efficiency, like use of passive design, the orientation, shading, and insulation. And renewable energy integration like solar energy, wind energy, and reduction of HVAC loads. Second is material ecology, like use of low impact, recyclable and non-toxic materials, the life cycle assessment of materials, and avoid harmful chemicals with VOC reduction. Third one is water management, like rainwater harvesting, grey water recycling, and efficient plumbing systems. Fourth one is indoor environmental quality, like good ventilation, thermal comfort, daylighting and glare control, and acoustic comfort, which is important in HVAC design. And fifth one is waste management, like construction waste reduction, recycling, and reuse strategies. So what exactly is building ecology? An ecological building is a structure that is designed to create and sustain mutually beneficial relationships with all of the elements in its local ecology. A building's local ecology or environment is made up of particular physical and biological elements and their interactions. The abiotic or physical elements are defined by the local geology and the local climate. The local geology is defined by the soil type, substrata, local land use and water patterns of the site and its surroundings. The local climate is made up of the weather patterns, wind patterns, solar patterns and pollution patterns for the site and its surroundings. The biotic or living elements are all of the local species and local ecosystems, including humans and urban ecologies that interact with the site. Abiotic components or abiotic factors are non-living chemical and physical parts of the environment that affect living organisms and the functioning of ecosystems. Abiotic components include physical conditions and non-living resources that affect living organisms in terms of growth, maintenance, and reproduction. Abiotic factors can include water, light, radiation, temperature, humidity, atmosphere, and soil. Building life cycle concept. A building life cycle refers to the view of a building over the course of its entire life, In other words, viewing it not just as an operational building but also taking into account the design, construction, operation, demolition, and waste treatment. It is useful to use this view when attempting to improve an operational feature of a building that is related to how a building was designed. For example, overall energy conservation. Life Cycle Assessment LCA. Now, Life Cycle Assessment LCA, also known as Life Cycle Analysis, Eco Balance, and Cradle to Grave Analysis. It is a technique to assess environmental impacts associated with all the stage of a product's life from raw material extraction through materials processing, manufacture, distribution, use, repair, and maintenance, and disposal or recycling. The goal of LCA is to compare the full range of environmental effects assignable to products and services by quantifying all inputs and outputs of materials flows and assessing how these material flows affect the environment. This information is used to improve processes, support policy, and provide a sound basis for informed decisions. Current research is ongoing in exploring methods of incorporating a whole life cycle view of buildings, rather than just focusing on the operational phase as is the current situation. The National Institute of Standards and Technology developed the Building Life Cycle Cost programs to provide computational support for the analysis of capital investments in building. They include BLCC, the Energy Escalation Rate Calculator, Handbook 135, and the annual supplement of Handbook 135. The life cycle cost of a building construction project includes the following. First is land acquisition, including assembly, holding, and improvement. Second is planning and feasibility studies and consultancy charges. Third is architecture and engineering design. Fourth is construction, including materials, equipment, and labor. Fifth is field supervision of construction. Sixth is construction financing. Seventh is insurance and tax during construction. Eighth is owner's general office overhead. And ninth is equipment and furnishing not included in construction. 10th is inspection and testing. Others are like operational and maintenance costs and etc. Thank you for watching this video and thank you from architect Neha Bhasin and engineer VK Jain sir.
Thanks once again from VK Jain for peacefully and meaningfully watching this presentation. Thanks once again.